आशीष,
Present, ma'am.
Present, ma'am. Present, ma'am.
आशुतोष,
Present, ma'am.
चमन,
Present, ma'am.
रितीश,
Present, ma'am.
हितेश, हितेश, हर्ष, कौस्तव मित्र,
Present, ma'am.
नील जैन, नील प्रेजेंट, पल्लवी,
Present, sir.
कुणाल दास,
Present, ma'am.
प्रत्युष,
Present, ma'am.
प्रेमचंद्र,
Present, ma'am.
यम, यश, रानाजय, रविराज,
Present, ma'am.
ऋषभ,
Present, ma'am.
प्रसाद,
Present, ma'am.
ऋतिका,
Present, ma'am.
समुद्रनील, समुद्रनील, समुद्रनील क्या हुआ उसका? सर्वजीत,
Present, ma'am.
सात्विक,
Present, ma'am.
सत्यम, सत्यम स्वामी,
Present, ma'am.
Present, ma'am.
सत्यम प्रेजेंट,
Yes, ma'am.
सैनी,
Present, ma'am.
शशांक,
Present, ma'am.
शशि,
Present, ma'am.
शुभम,
Present, ma'am.
सिद्धांत,
Present, ma'am.
सोहम,
Present, ma'am.
सोमेंदु, सौरीन, सौरीन, शुभम, शुभ्रदास,
Ma'am, he left the university.
शुभ्रदास, सुप्रसाद,
Present, ma'am.
सुप्रतिम,
Present, ma'am.
सुरचिता,
Present, ma'am.
सुश्री,
Present, ma'am.
सुयश प्रेजेंट, तारीश,
Present, ma'am.
तारीश, उत्कल,
Present, ma'am.
विवेश,
Present, ma'am.
रितंकर,
Present, ma'am.
आंचल,
Present, ma'am.
अमन,
Present, ma'am.
टिपंजन,
Present, ma'am.
अभिजीत,
Present, ma'am.
आदर्श,
Present, ma'am.
आकाश,
Present, ma'am.
अनन्या,
Present, ma'am.
अनंत,
Present, ma'am.
अनन्या सिंह,
Present, ma'am.
अनिका,
Present, ma'am.
अंकित, अंकित, अर्नब,
Present, ma'am.
आर्यक,
Present, ma'am.
आर्यमन, आर्यमन, प्रखर,
Present, ma'am.
आयन,
Present, ma'am.
आशीष,
Present, ma'am.
वैष्णवी, भव्या,
Present, ma'am.
समृद्धि, सत्य,
Yes, ma'am.
सत्यव्रत, सत्यव्रत प्रेजेंट, सौरभ,
Present, ma'am.
सायक,
Present, ma'am.
सायन, शिवम,
Present, ma'am.
शुभम, शुभम, एब्सेंट, सौभाग्य,
Present, ma'am.
शुभ्रांशु,
Present, ma'am.
शुभ्रांशु,
Present, ma'am.
सुप्रिया, सुप्रिया,
Present, ma'am.
स्वप्नदीप,
Present, ma'am.
उत्कर्ष,
Present, ma'am.
वैष्णवी,
Present, ma'am.
विनीता,
Present, ma'am.
अजय शंकर ऑप्शन, अमीश,
Present, ma'am.
अनुराग,
Present, ma'am.
अनुष्का प्रेजेंट, अर्पित,
Present.
आर्यन, आर्यन, आयुषी,
Present, ma'am.
विभू कल्याणी प्रेजेंट, चेतना, चेतना
Present, ma'am.
प्रेजेंट, छवि, छवि, छवि एब्सेंट, My board is visible, see?
Yes, ma'am. Visible, ma'am.
Yes, ma'am.
Okay, so today we will start the next module, that is fundamentals of AC circuit.
Ma'am, next topic or chapter?
Next module,
What?
AC circuit. This one you will get it in the mid-semester exam. AC circuit. This is over. So now, till now, you have read about the DC circuit, okay, where the currents was constant, the magnitude of the current was constant, and the direction was in a single direction, the current was flowing, okay. So these DC circuits which you have read it in the earlier chapter, this is very few, or we can tell that very limited application, okay. Like your for example, when you are charging batteries, you are using the DC supply, yes or no? Like you're charging the laptop, charging your mobile phone, okay, it is very. Then in electric traction also we are having some applications, okay, but these applications are very much limited, okay. So but if we kind of compare with an AC system, AC has a many advantage. At present, actually the main advantage is that your electrical energy, somebody will ask you what is the advantage of AC circuit over the DC system. So advantage of AC circuit is, or AC system, particularly advantage of AC system, where the system is having circuits, AC circuit. So the main advantage is that electrical energy is universally generated. Electrical energy is universally generated. It is, the generation is done in AC, then transmission is also done in AC, and distributed in the form of what? In the form of AC. Clear to all of you? This is the main advantage of AC. Why we will be reading AC circuit? Okay, and wherever is required, as I have told you, the DC circuits is having very few or limited applications. So where you require DC, suppose you require DC to charge your laptop. So what you are doing? To your home, you are getting an AC supply, but how you are charging the charging your laptop? Tell me. That requires a DC, because battery when you are using, that is a DC supply is required for charging of the battery. Yes, tell me. So how you are getting that DC voltage?
Using rectifier.
Using rectifier. Okay, you are using a rectifier. Just. So you are using a rectifier to convert that AC to DC. Clear? So you are using that rectifier as a converter. So you have seen within your laptop charger cord, you will see in the middle of that a rectifier, or that is a converter or adapter, what we call it. Okay, that is a nothing but a converter. It's similar in the mobile phones, you are also seeing that is a adapter. That is converting the AC supply to the DC supply. Okay, so when you are connecting your mobile to the AC supply, that is a converter of the adapter. It is converting to the DC supply. Clear? So wherever is required, we are converting the AC power to the DC power, or the AC voltage to DC voltage. Okay. So AC circuit is, as I have told you, it is having many advantages because due to the generation, transmission, and distribution, universally it is adapted in the form of AC. Okay. So also there are many advantages, like you are using AC motors. AC motors are usually cheaper than DC motors. Okay, and we can step up and step down the voltage according to our requirement if we are using AC voltage. Okay, AC with the help of transformer, you can use step up or you can step down the voltages of the currents or the power or the energy. Okay. but which you cannot do it. It is very difficult. You can do it because now advancement has gone, but it is easier when you are using AC. So stepping down the voltage with the help of step up and transformer is easier. Okay. So what is the main advantage of some question will come? What is the advantage of AC circuit over DC circuit? You can write it down. Yes or no?
Yes, ma'am.
Okay. So now next come to what is the definition of AC? How you define an AC? Tell me. This is a simple question which you have already read. How will you define AC? AC means what? Alternating circuit. AC current or AC voltage means what? We add a current or voltage term even if we are telling that is alternating. It is alternating circuit. AC current when you are telling AC current when you are telling, it implies that is a current and AC voltage. Okay, AC voltage and AC current. How will you define both these terms? Tell me. You have already read it in 12th standard, so I expect that you can answer this question. Tell me, how will you define an AC voltage? Tell me. How will you define an AC voltage? Tell quick. How will you define an AC voltage? You can define or not?
Changes with respect.
Yes, tell. Let
Ma'am,
it be wrong, so what?
Whose magnitude and polarity changes with time.
Yes. When remember that this I have already told you previously. I was expecting the answer. Very few are answering. So voltage, when you are talking about voltage, you will talk about its magnitude part, and you will talk about its polarity part. Okay, the magnitude and the polarity changes with respect to time. Okay, and when you will discuss about the current, AC current, you will talk about the magnitude and direction. When you are telling about the current, so here you will tell about the magnitude and about the direction. Okay, so AC voltage we will define as that voltage whose magnitude, here I am writing the definition. Here the magnitude, it is that voltage whose magnitude and polarity, that voltage whose magnitude and polarity what changes with respect to magnitude and polarity changes with respect to what? Tell me. With respect to time. Okay. Similarly, I will tell about the definition of AC current. You understand my handwriting, all of you? Where you will not be able to understand, tell me. So AC current you will define as it is that current whose magnitude and and what? Current means what you will tell? Magnitude and direction changes with respect to time. This is the definition of AC voltage and AC current. Got it, all of you?
Yes, ma'am.
Anurag, you understood?
Yes,
Anurag, Adarsh, Anvik?
Yes, ma'am.
Now come to the sinusoidal alternating voltage and current. Here you see, when I am telling about the voltage, consider the voltage. What I have told you, its magnitude changes, its polarity changes with respect to time. Okay, so there can be a different types of AC voltage. Written all this thing. Okay.
Yes, sir.
So if I will tell you answer my question here, if I will show you this waveform. You see, you can tell it as an AC. Understand properly, all of you. These are very fundamental things which I am discussing. Unless you understand the fundamental here, you will get maximum problems. This is not at all a theoretical part. Concepts will be very clear. So here I have shown you two waveforms. Okay, one is a triangular type, another one is a sinusoidal waveform. So can I tell that this is a waveform, this is an alternating, the waveform is AC, AC waveform, this is AC, this is also an AC waveform, yes or no?
Yes, ma'am. Yes.
Yes, ma'am.
Yes, you
Yes,
have
ma'am.
to
Both
tell
are
why.
AC.
Yes, another one also I can draw, this one, yes or no?
Yes, ma'am. This is
Yes,
also
ma'am.
Okay,
Square.
but throughout your syllabus, we will be discussing only this type of waveform, sinusoidal waveform. Okay, why sinusoidal? Question will come to your mind, why sinusoidal waveform? To our home, we are also getting this type of supply. AC supply which you are getting, the magnitude and the polarity is changing with respect to time. So these type of waveform we are getting at our home, not this one, not this one. So now question will come, as when discussing about sinusoidal waveform, why not all these types of waveform? Why not triangular? Why not square? It's this type of waveform also the magnitude is changing, as well as the polarity is changing with respect to time. So question will come, why sine waveform? Why sine waveform? Let's make a heading. Why? Question will come, this one to your mind. So can you tell me what is the advantage of why we are going for sine waveform? Tell me. Yes. Why we are not going for square waveform? Why we are not going for triangular waveform? All this magnitude is and polarity also is changing with respect to time. Tell me. How you are using your simple question I'm asking you. You are using your using your fan. You are using the washing machine, grinder, whatever the appliances which you are using at your home. All are working on AC. Yes or no? To your home, you are getting AC voltage. Yes or no? Got
yes,
it or
ma'am.
not? All of you got it or not? Respond, all of you.
Yes, ma'am.
How many
Yes,
students are
ma'am.
there? Not-
Yes,
Yes,
Okay.
ma'am.
So now you are using AC voltage. That AC voltage you are not generating. Are you generating or using? You are only purchasing and you are using. Your father is paying the electricity bill and your house is connected somewhere where that is giving the supply to your house. You are only there to use it. Are you generating that? No. Yes or no? So now somewhere the power is generated in the generating station. In the generating station, whatever the power is generated, that is in the form of AC. Okay, that is in the form of AC. So now the question will come: why you are generating the power in the form of AC? Just wait one second. Okay, so here my board is visible. Yes,
Yes,
my board is visible.
yes, ma'am.
Yes, ma'am.
Yes, ma'am.
It's visible, ma'am.
Okay. So now here, as I was telling you, now the power which we are generating at the generating station, that we are generating an AC power. Okay. So now here, that AC power which is, as I told you, the AC voltages, it can be a triangular because its magnitude is changing with respect to time. It can be square. Okay, that can be different waveform. But voltage which you are generating at the generating station, that is in the form of sinusoidal waveform. So question comes, why sine waveform? Why we are not generating a triangular waveform? Why we are not generating a square waveform? Why we are not generating a rectangular waveform?
Ma'am, because
Can you tell me one
in
of the
sine,
advantage? Tell.
I mean sine, ma'am, it has the same frequency and magnitude.
Speak loudly. I'm unable to listen.
Ma'am,
Yes,
because
tell.
it has same frequency and same magnitude.
Same frequency and same magnitude. Magnitude does not change. That is the basic definition of AC voltage. Magnitude does not remain constant. That is the basic definition of AC voltage. Just now I have told you, na?
Ma'am, I'm telling for the sine, ma'am, that why it is used, ma'am, because it has the same frequency, due to which it maximum time it's used.
No, frequency is same. Frequency, there also frequency is same. Square method. Just wait, I am saying. Hello? Hmm. Hmm. ମୁଁ ତ ଗୋଟେ କ୍ଲାସରେ ଅଛି ଗୋଟେ ମିନିଟ୍ yes, tell me why you are
Ma'am. क्योंकि वो जनरेट करना आसान होता है उसको.
Frequency is same. See, frequency is same. Here you see, if I am taking a square weapon, I will be having same frequency. After 180 degree, 360 degree, again this one will be your what? The frequency. If I will use this waveform, I am showing you this waveform. This is having the frequency same. Here also same frequency. Frequency will be same. Why?
मैम उसको जनरेट करना आसान होता है.
जनरेट करना आसान होता है. नियर टू द आंसर.
कोई भी चीज को साइन पे ऑसिलेट करना आसान रहेगा in comparison to triangular or square.
Okay, one of the reason you are telling, you have approached the answer. Okay, here I am telling you, if you are generating a sinusoidal waveform, a sinusoidal voltage or current, they produce. First point is they produce very less iron and copper loss. Very less iron, that will be loss, na? Iron and copper loss, okay, in the system. Copper loss for a given output. This is one of the main advantage. Understood? So efficiency, if loss is less, what happens to the efficiency? The performance will be better. Efficiency is more. Am I clear to all of you? Got it? Got it, all of you?
Yes, sir.
Second one is, tell. Yes, somebody is asking. Tell, ask a number of questions. Don't worry. Anybody
Yes,
is
ma'am,
asking? Okay. So now second is, it produce very less interference with the telephone lines. Very less interference. Telephone lines we have with the transmission, your power lines. Yes or no? Yes or no?
Yes, sir.
Transmission lines are, yes. So they produce very less interference on the communication lines or telephone lines. Very less interference. Next, another point is they produce, third point is produce very less disturbance, produce very less disturbance, produce very less disturbance in the electric circuit. In the electric circuit. Disturbance means sometimes there is unwanted signal in electric circuit. that we call it as harmonics. Okay, have you heard this term?
Yes,
Have you
ma'am.
heard this term? Harmonics, unwanted signal comes. Okay, so in this case, when you are generating an AC voltage, they produce very less disturbance in the circuit. Okay, and is very smooth. Here harmonics is less and is smooth and is smoothest and efficient, as I told you above, in the efficient waveform. Okay, so due to these are the main advantage of this sinusoidal waveform. Okay, so that is why all the electrical companies throughout the world, they generate sinusoidal alternating voltages and currents. Got it or not? So when I will be, all of you understood, universally the voltage or the AC voltage generated are in sinusoidal waveform. Okay, they are in sinusoidal waveform. So unless otherwise stated, if it is not stated at all, alternating voltage, if I am speaking alternating voltage, implies that I am speaking only about sinusoidal voltage, not triangular, not square, not rectangular, whatever. Alternating voltage, or if I am telling sinusoidal voltage, both are same. Alternating voltage means we will be discussing only about the sinusoidal voltage. Am I clear everything? Clear to all of you?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Now come to generation of, so sinusoidal waveform. What is the alternating equation of the sinusoidal waveform? Tell me. Alternating voltage equation of sinusoidal waveform. Quickly tell. So many students are there. You should ask. Alternating voltage implies this is equivalent to your sinusoidal voltage. Sinusoidal. What is the equation of sinusoidal waveform?
MA sin omega t.
What?
V0 sin omega t.
साइनोसॉइडल वेवफॉर्म का इक्वेशन अभी बोलो, नहीं कल क्लास बंद करके
A sin omega t
A
plus
sin omega t.
ये साइन ओमेगा टी, ये क्या है? ये
Maximum
साइनोसॉइडल वेवफॉर्म है, इसका क्या इक्वेशन है?
MA maximum magnitude होगी.
मैक्सिमम तुम्हारा जितना होगा उसका.
V0.
So this is your sinusoidal voltage. Suppose I am telling it as V. V will be equal to how much? V will be equal to Vm. If Vm is the maximum value, then into sin omega t. What is omega?
Angular frequency.
Angular frequency. कहाँ सब टर्म ले आ रहे हो तुम लोग? Angular velocity. Is omega is the angular velocity. Okay, Em is the maximum value, and this V we call it as instantaneous value. That I will discuss later on, not now. Okay. Instantaneous value. Instantaneous value means at a particular instant. Okay, that means suppose I will ask you what is the value of the alternating quantity or alternating voltage as t equal to 1 second. I will tell t equal to 1 second. Okay, so that value will be different at t equal to 2 seconds. Yes or no? Will be different at t equal to 10 seconds. Got it or not? So here the t value is changing, right? Got it or not? All of you understood? So the instantaneous value is changing. Those who are not able to understand, please take. Okay, don't feel any type of sigh. So here what happens? Instantaneous value is changing according to the value of your time. Got it, all of you? According to the value of time, the instantaneous value is changing. Okay, so that is why it is. I will discuss later on all the values. Don't worry now. So now come to the generation of how we are generation of alternating voltages and current. generation of alternating voltages. Soham, you understood or not?
Yes, ma'am, understood.
Very good. Siddhant?
Yes, ma'am.
You understood?
Yes.
Very good. Okay. So there are, if I will ask you how you are generating the alternating voltage, there are two ways in how you can generate an alternating voltage. These are very basic things. Okay, you will get it in this exam only. So an alternating voltage can be generated. It can be generated in two ways. Can you tell me what are the two ways? What are the two ways? Tell me. Alternating voltage can be generated in two ways. What is the first? As I have told you, Faraday's law, Faraday को मत भूलना कभी भी. तुम्हारा नाम भूल जाना, Faraday को मत भूल. Due to Faraday only, you are now getting the electricity. When you wake up, you are using the mobile, you are using your laptop, a fan, a bulb, AC, whatever may be. It is coming from the electric supply. Okay, that supply you are not generating, that is generated in the generating station, and the generating stations are using Faraday's laws of electromagnetic induction. Okay, so same here, AC voltages are generated according to Faraday's laws of electromagnetic induction. What Faraday has done the experiment? While doing his experiment, he observed that when he rotated a coil or conductor inside a stationary magnetic field, a magnetic field was there. Listen all of you carefully. When he rotated a conductor inside a stationary magnetic field, here the conductors are there. What he did? He just rotated the conductor inside a stationary magnetic field. This is my magnetic field. This is the magnetic field. What he did? He rotated conductors inside the magnetic field. And he observed that the voltages are generated in the conductor. Okay. And if he has closed the circuit, a current is flowing. He observed this in the experiment. Understood all of you? Is there any doubt? Faraday's law you already know. Second thing, he also observed that what he did, he rotated the conductor inside this was stationary and this one conductor was rotating. The conductor was rotating and the field was stationary. In the second case also, he observed that if he is making the conductor stationary, if conductor stationary and he is making the field rotating, magnetic field will be rotating and conductors will be stationary. Got it or not? All of you understood or not?
Yes, ma'am.
All of you?
Yes, ma'am.
Okay.
Yes, ma'am.
Very good, very good. So here, second thing he also observed that when he has maintained the conductor stationary, this conductor is stationary and the field is rotating. He also observed that here the voltages are also induced across the conductors. So from these two experiments, he concluded that when there is a rate of change of flux, then an EMF is induced. He is getting the voltage in both the case. What is the first case? First case is if you will maintain the field system stationary, conductor rotating. Conductor you rotate inside a magnetic field, you will also observe, you can also do this experiment. You rotate the conductors inside the magnetic field, you will get an EMF. You rotate the field inside a stationary conductors, there also the EMF will be induced. You will get the EMF. Am I clear? Both the steps? Understood or not? Tell me. Got
Yes,
it,
ma'am.
all of you?
Yes, ma'am.
Yes, ma'am.
Okay. So in both the cases, first case is by rotating the number 2 second above I have written by two methods. By rotating, write down this one. By rotating a coil at constant angular velocity, in a uniform magnetic field in a uniform magnetic field in a uniform okay, here I'm writing. Written here, second first point write down, by rotating a coil at constant angular velocity in a uniform magnetic field. In a uniform magnetic, written all of you.
Yes, ma'am.
Second point, write down. In the second case, by rotating a, what I have told you, one constant, one rotating. By rotating a magnetic field, yes, tell me, at a constant angular velocity, angular velocity.
I'm changing over rotating.
By rotating a coil. Yes.
Rotating a magnetic field. Second is rotate. You have to rotate the field. First one is you rotate the coil inside a constant magnetic. Conductor rotating, field stationary. Second case, field rotating, conductor stationary. Got it?
Yes, ma'am.
Who was asking? Got it? Who was asking?
Yes, ma'am.
Yes, ma'am.
Yes. So at constant angular velocity within a stationary coil. Within a stationary coil. So in both the cases, first case is field stationary, conductor rotating. Second is field rotating, conductor stationary. Okay. In case of a DC generator, see, in case of a DC generator, you are generating voltage. In case of a AC generator, you are generating the voltage. In case of a DC generator, what we are doing, listen to me carefully. In case of DC generator, you are generating voltage. In case of an AC generator, you are generating the voltage. But in DC case, what we are doing, we are using the first step. We are keeping the fields constant, conductors rotating. In case of your generating stations, they are making the field rotating and conductor stationary. So they are having advantages. So that we will discuss later on in the machine part, not now. But in case of your generating stations, we are using the second. Principle is same, Faraday's law. But the process we are doing it is, this is in case of your generating station or AC, when you are generating AC power. Got it all of you or not? Tell me.
Yes,
understood? And this first case, all of you understood? Girl side? Ritika, you understood?
Yes, ma'am.
Pallavi understood? Pallavi, Ayushi, Chetna, Chabi? Understood? Okay.
Yes, ma'am.
Say first one we are using it for which system I have told you, in case of a DC system, DC generator. Okay. And that one in AC. But in both the cases voltage is generated. Okay. We will discuss details in the class, and in the lab also we will be having one experiment is there. That I will discuss. Clear to all of you? Now here I will tell you how we are generating this AC voltage. All of you have written. Now here I am taking a stationary field. What I am doing? Make a heading, equation of J, alternating voltage and current. Alternating voltage and current. Equation of alternating voltage and current. Okay. So here what I am doing it is, I will take a stationary field. Do it quickly, huh? Stationary field I am taking. What I will do it is, I will rotate the conductors. First case I am doing. Here I am taking a conductors having n number of turns. Okay. This conductor is of rectangular shape. Initially, the position of the conductor is like this. Now, what I will do, I will rotate the conductor. Second case, what is this? The first case, my conductors. This is the second case. Here, the field is constant, or field system is stationary. Field is not rotating. What I will do it is, I will rotate the conductor. I will rotate the conductor. The conductor new position is, suppose at this instant, the conductor is placed. Okay. Got it, all of you?
Yes, ma'am.
Yes, ma'am.
Just. So here this is rotated at an angular velocity of omega radian per second, and this is your original position. So what will be this displacement theta? What will be the value of theta? Tell me. What will be the value of this theta? Theta is this angle. Omega. Theta is equal to how much? Omega into T. Yes or no?
Yes, ma'am.
Okay. So this angle, it is rotated to a new position. That position is your, it has rotated at an angle theta. It is kept at an angle theta. Okay. So now at this position, this is your maximum flux. This is your maximum flux, phi maximum. Phi maximum. So now here, this at this position, all of you will retain. I will see. Draw it first. Then I will explain. Complete? Completed all of you or not?
Yes, ma'am.
Okay.
Yes, ma'am.
So I will sit here. So now here you see at this position, phi maximum is the maximum is the maximum flux that is acting vertically downward. Okay, so this can be resolved into two components. What is your first component? If I will resolve the flux phi maximum into two components, one component will be the along the line of the conductor, that will be this one. This one will be case. Okay. So this is your phi maximum. How much? Tell me. This will be this component which I have shown it in the arrow mark. This will be your phi maximum. How much? Tell me. Theta is your omega t. This is phi m sin omega t. Yes or no?
Yes, ma'am.
And this one will be your, this component will be your how much? Phi m cos omega t. Got it or not, all of you? All of you got it or not?
Yes, ma'am.
Understood or not?
नहीं समझे
हाँ?
नहीं समझे
क्यों नहीं समझे? Just wait.
ओह यस समझ गए
समझ गए? कुछ भी नहीं की सिंपल.
नहीं मैम डायग्राम
ऑल ऑफ यू अंडरस्टूड? हाँ ठीक है देखोगे समझ में आएगा उसमें कुछ.
Yes, ma'am.
Got it, all of you? Okay, very good. So now here you see we are having two components. So this component, because it is not cutting the magnetic flux, if I will ask you, is this component cutting the magnetic flux? Phi m sin omega t? Is this component cutting the magnetic flux? Listen all of you carefully. Phi m sin omega t, is it cutting the magnetic flux? It is acting along the line of the conductor. Yes or no? Got it or not? If this component is lying along the conductors, it has no contribution for the production of the induced EMF. Why? Because it is acting on the same line of the conductor. It is not cutting the magnetic flux. So only component is this component which is responsible for the production of what? Induced EMF. Am I clear now? Am I clear to all of you or not?
Yes, ma'am.
All of you understood. Again, I am telling you, this is acting. I am telling you. Don't worry. So this component is acting along the line of the conductor, as it is not cutting the magnetic flux. So it has no contribution for the production of the EMF. But this has contribution for the production of the EMF, because this is cutting the magnetic flux. Am I clear now to all of you? Got it or not? All of you understood or not?
Yes, ma'am.
Yes, ma'am.
Okay. So here I will find out what is the equation of the induced EMF. Now here you see, what is your Faraday's second law? Faraday's second law he has told that, what is your second law? Faraday's second law. The magnitude of the induced EMF is equal to the rate of change of flux linkage. First one, he has told that EMF can be induced when there is a rate of change of flux. Second law, he has told that the magnitude of the induced EMF is equal to the rate of change of flux linkage. Yes or no? So what is your flux linkage? Flux linkage is what? Tell me. That is equal to number of turns where the flux is linking. Number of turns multiplied with how what? Flux linking. Am I clear or not? Suprasad, you understood?
Yes, ma'am.
So this is equal to n is the number of turns multiplied which, as I have told you, which component is having the contribution? Which component is having the contribution? Phi m, how much?
Cos omega t.
Omega t. This flux is having the contribution because it is cutting the conductor. Okay, because first law tells that when there will be a rate of change of flux, when the flux is changing with respect to time, that is linking the conductor, the EMF will be induced. So this is your, now come to what is your, according to Faraday's laws of Faraday's second law, E will be equal to how much? EMF induced according to, write down, according to Faraday तुम लोग पढ़े थे ना ये 12th में या नहीं पढ़े थे?
मैम पढ़े थे
यहाँ पर है पर
मैम पढ़े थे लेकिन भूल गए
नहीं Faraday का लॉ को मत भूलना, because Faraday only you are getting the electricity rule. Faraday's law don't worry. This is very simple, very fundamental. तुम जितना भी कोडिंग करो, जो भी करो, इसको मत भूलना. Okay. So according to Faraday's laws of electromagnetic induction, second law, there are two laws. So E is equal to how much? E is equal to rate of change of flux linkage. Rate of change of flux linkage. तुम्हारा EMF वोल्टेज जनरेट होगा तो तुम्हारा कंप्यूटर स्टार्ट होगा। दिस आर वेरी फंडामेंटल, हम लोग को इसको जो भी ब्रांच हो ये वेरी फंडामेंटल, यू शुड नॉट forget this one. So rate of change of flux linkage is equal to how much? So this will be equal to how much? Differential d phi by dt. What is your, which one is contributing? Phi m cos omega t with respect to dt. And here we will put a minus sign. Why minus phi sign? This is for which law? Lentz's law. Okay. Where there is a Faraday's law? The Lenz law is there. It has,
Yes,
he has observed that it will it will oppose the cause producing it, which has produced the EMF. It will oppose that. Understood or not? Got it?
Yes, ma'am.
Okay. So now here you find out what is the differentiation and tell me. So now what is your equation? E is equal to how much? Minus differentiation of phi m cos omega t. Okay, so this is equal to how much? N number of turns, n phi. Rate of flux linkage, na? Arey, what is the formula? Rate of change of flux linkage. What is the flux linkage? Here you see, what is the flux linkage? Flux linkage is how much? This
N
much, right?
into phi m cos
N.
omega t.
So you are forgotten to write down n. So you should not forget to write down n. ये सब तुम मेरा मिस्टेक देखोगे ना, वो बोलोगे स्किप कर देती हूँ, यहाँ पर जाकर के देख रहे हो नहीं है उनका n. Okay, so this will be equal to how much? Minus n. How much? Tell me. Phi m omega minus sin omega t. करेक्ट है या नहीं बोलो? एक तो छोड़ते नहीं.
Correct, ma'am. Yes, ma'am.
Very good. Pi n omega, then what? Sin omega t. Okay. So maximum value you will get, when you will get the maximum value? When this one will be equal to how much? When this one will be sin omega t is equal to how much? Tell me. 1.
1 man.
Okay, so E is equal to Em, that is equal to n phi m into omega. So from here I am getting E is equal to Em sin omega t. Clear to all of you or not?
Yes, ma'am.
Understood all of you? Got it or not? Tell me.
Yes. Yes, ma'am.
Next class I will similarly I will be equal to Im sin omega t. Okay, next class I will tell you some terms. Here this very basic. Tomorrow will be your last class. Your syllabus will be over. Okay. Join tomorrow class positively all of you. Written all of you. So here. This is your sinusoidal waveform of voltage, sinusoidal current. This is sinusoidal voltage and current. Okay. Understood all of you? Any doubt? Tell me. Anybody having any doubt? Tell me.
मैं एक बार वो अकॉर्डिंग टू फैराडेज लॉ से पहले वाला पार्ट दिखाइएगा ना, वहाँ पे छूट गया।
दिखाऊंगी या समझाऊंगी? क्या बोल रहे हो?
मैम बस दिखाइएगा, थोड़ा छूट गया मेरा।
कौन सा वाला? ये वाला?
हाँ, थैंक यू।
Faraday's second law tells that E is equal to rate of change of flux linkage. Second law he has told about the magnitude. First law he has told how the EMF can be generated. Second law he has told what is the magnitude of the induced EMF. Written?
Yes.
Okay,
Yes, ma'am.
I have taken the attendance. You leave. You are having class.
मैम कल
Thank you,
वेडनेसडे
ma'am.
बोल रहे थे क्विज लेंगे।
हाँ क्या बोल रहे हो?
मैम you told मैम in on Wednesday you are going to take a quiz.
सुनाई नहीं दे रहा है, जोर बोल जोर से।
मैम आप बोले तो वेडनेसडे को एक क्विज लेंगे।
वेडनेसडे को क्विज क्लास में ना?
हाँ मैम बोल रहे थे भैया।
मैम जरा फ्राइडे कर दिए थे डेट।
फ्राइडे कर दिए थे मैम।
फ्राइडे
7th
हाँ फ्राइडे कर दी थी। फ्राइडे
Yes,
में
ma'am.
लूंगी, फ्राइडे।
ओके मैम।
फ्राइडे
वेडनेसडे कल सुनो,
Okay.
कल मेरा कंप्लीशन ऑफ सिलेबस होगा।
यस मैम।
और थोड़ा थोड़ा टर्म से, और ज्यादा कुछ नहीं, टर्म से नेक्स्ट 1 class only I require. Another class Friday, that will be a doubt clearing class. Doubt तुम लोग नहीं पूछोगे तो I will ask, and also attend the class, doubt clearing class with a quiz test. I will do. Class में ही quiz करना.
मैम
और-
फ्राइडे
हाँ।
7 PM इवनिंग को।
अरे तुम लोग का क्या फ्राइडे है? फ्राइडे क्लास में दे दोगे 10 मिनट का क्विज टेस्ट.
मैम 10
मैम फ्राइडे तो गुड
Friday actually
फ्राइडे है.
Yeah.
गुड फ्राइडे